Hi, my name's Michael Crawford. I'm your training instructor for this demonstration. Today we're going to cover creating DSTV CNC NC1 files for beamline cutting. It's quite an involved process to understand how these files are created. Let's just go through the steps to ensure that we are going to produce the files correctly. There are some requirements beforehand to ensure that they can be. The first thing is, at the moment, our circular hollow section tubes cannot be produced to DSTV. That's just a limitation of the software. In the future it may be added, but at the moment we don't have that functionality. We can, however, do RHS, which is your rectangular hollow sections, and SHS, square hollow sections. So at the moment I'm just going to start you off and show you how this works and why it works the way it works, and get into great detail on the process. First of all, before we even think about creating DSTV files, we have to ensure that our items are consolidated. We consolidated before. I'm just going to bring the data in. So consolidation's brought the data in, and now you can see that we've got some consolidation data. What we're going to do is create a plate DXF, and then we're going to create some section DXF so that they all go together. Okay, and give you an example of how it all works. First of all, these are pretty simple sections. There's nothing in them, but what I will do is I will set it up so that we've got some data that sort of stands out, such as putting some holes in some sections. At the moment we've got no holes, so we want to produce the holes. So I'm just going to go down to this section here. I'm going to edit it in context. I'm going to put a hole on it, on the top flange. Just bring it out. And of course we work to gauge like everybody else, and I'm going to give it a distance from the end, and if I can't get the end I might have to go into the part. Sometimes that has to happen, or while you're working it might also pay to isolate your section. So if you right mouse click, go isolate, and then edit the sketch again, and now I can put a dimension on that end. So let's set it up so we've got 100, and we might want to put a 22 hole in there. We could probably do a through hole. Sounds like a good idea. Through all. There we go. And then we can put holes in the web. So let's go down the other end and put a hole in the web. So edit in context. Let's put 2 holes here. Now we can do slots as well. So I've just put 2 holes and make them equi, make them centered. Hang on, my bad, fix that up. So that make sure that line's vertical, and it is. And then I'm just going to put one centered by using the center of the face. Make that horizontal. Give it an edge distance of the standard 35. Going to make these 22 holes as well, and we'll give them 70 centers. And now we're going to cut through the PFC. And now we've got something that's different. But now that I've made changes to that, I'm going to reset my marks. So I clean it up, and there have been drawings issued, so it's only going to reset a drawing, a component mark. And if we look at this, it now has the mark of being section 2. It must have been the parent mark. The other mark now has moved over because this was one of them, so that's now separate. So now it's become section 3. So consolidations pick that up. So the section that we're going to want to select in this case to do our demonstration is going to be section 2. Save that. Get a DSTV CNC Export. We have a plate that's been collected, so we collect the plate. Let's create a file of that. So we just select the plate that we want to create and click create. It's collected the information and it's created the file for that plate. We've downloaded a product called Steel Projects. If you'd like to get a hold of that product, go to their website. They have a nice viewer that allows you to view the models. There are other better viewers. Unfortunately this one does not allow me to measure or check, so you might likely want to go and measure and check. So you're going to need to get another viewer, and in most cases a good viewer you'll have to pay for. See, in this one you can see that there is a mark at the bottom left hand corner. That mark can be modified in the file. If we want to modify the mark, we'll close it off. You can, if you understand DSTV, go in and modify this line because that's your mark line. The SI indicates that's where the mark is. You can change the position from the left hand end out and from the top, and you can even change the height, which is here. Alternatively, you can use our mark update part marking updating location. So in this case I might want to change its text height to say 25, which would make it too large, but it'll stand out. And then vertical position, you might want to make that say 20, and you might want to make the horizontal 20. And the face that it's on, typically for plates, is the V face, which is the top face. If you click update, you can see it changed that location on the file, and then we click save and then open the text file, and you'll see that that's changed on that plate now. If it overlaps holes or it's off the plate or one or the other, you may have to go in there and manually change these. If it's over the top of a hole, you obviously don't want it over the top of the hole. You may have a standard height that you want to engrave the plate to mark the plate, and your text height might have to decrease. If we go over to the section 2 is the one we want. Now if you don't see these images updating, it means that the actual part was modified in context of an assembly and the actual image itself has not updated. So if we close it off, I'll show you what I mean. We're going to open that component up and zoom out, Control Q, Control S. Now if I go back to my DSTV, you'll notice that that image now will have updated when I click on section 2. And we now know that that is the section that we're going to convert. So we hit create, and that'll go through the process of creating that DSTV file for that section. So it takes section cuts through the web, it takes section cuts through the flanges and selects the face information and collects that information and creates the DSTV file from that. So we can open the text file up now and have a look at what that NC1 file looks like. So you can see this end, this is our 2 holes that we created, and then there's our 2 holes in the base, in the web. Okay. Now, things that you need to know. This was a very simple channel. The flanges are parallel. That being said, because the flanges are parallel, we don't need to create a file that is going to be swapped out. Now what I mean by a file that's swapped out, let's open up and have a look and I'll show you what I mean. Before we do that, I'll show you what's happened with the folder location for it. So when we created the DSTV export, it's put it into the project and it's filed it under plates. So there's the file, and it's stuck it under the section. If you have any issues with any of these files, just zip up the component, which it takes a snapshot of the component, okay, and it forms an assembly to which it puts it in, and then it saves it out as a component and moves it into a position where we can collect the information. The final file is the DSTV file. That's the one that we're mainly really interested in, but it's always good to just zip these up and send them to us, and the NC1 file. So if you have any problems, please do that. Add them to a folder and zip them up and send them to us. If it's just one problem, just select these items and group those. Don't select the whole lot and send us the whole lot. We just want these, and we just want the NC1 file. That helps us do any debugging or find any issues that may have caused the NC1 file to fail. That's the folder system. Plates, they're just simple, just an NC1 file. We don't need to create sections for those. Plates are fairly simple. Okay, so now let's check out what actually happens behind the scenes so that you can see when we have non-parallel flange channels or angles with lip surfaces and things like that. So if we go to our library under Steel Designer Pro library, pick your standard, in my case it's Australian, go into your weldment profiles, ANZ for us, and then I'm going to go into the stock standard BHP. You'll notice that in our weldment files we have a couple of different weldment profiles that have DSTV-EA in front of it, or -TFB or -UA. In your country you might have tapered flange channels. Tapered flange channels, we cannot get the surface. We actually have to modify the weldment profile and take away the edges. If you can imagine, in this particular case, the UA being an unequal angle, and then we go down to UA being an unequal angle, you'll see that there are radiuses on the legs. When we want to collect the information behind this, we have to have a flat surface that's parallel to one another, or a cut surface. We can't have curved radiuses. So what happens is in the process of creating the weldment profile creating the section for the DSTV, it temporarily swaps out the angle weldment profile for a DSTV weldment profile, and you'll see the radiuses disappear. So when it takes a section cut, it cuts it down the inside sketch segment that you see there and forms a plate, and it'll do the same thing on that edge. It'll cut it across there and form a plate. What happens is that whether you've got a lip on this side or a lip on that side, it has to reiterate through each edge to work out whether or not there's a bevel cut. If there is a surface that is curved, it's not considered a bevel cut, and it causes problems. The only way that we've been able to solve this is to swap it out and put in a replacement that doesn't have the edge cuts. The same thing applies for a tapered flange beam, or a channel. The flanges themselves, if you look at them, they are sloped. In this particular case, this has been straightened up. The thickness has been applied to the point at which we call the thickness. And if you have a look at the tapered flange beam, you'll see that there is a taper. We need to remove that taper for DSTV so that we can get a straight plate, so that when we do cut across on the tapered flange, across the flange, it is a straight plate. Same with the base as well, for the top and bottom flanges. That's just a first step, something that you need to look at. All we did was we just grabbed the weldment profile and copied it and put DSTV in front of it, and then we went in and we just removed any parallel processes or removed any of the curved surfaces out of there so that we can get straight edges. And what that means is that by doing that, it's really easy, because just deleting the edge and then merging the points together made it easy that we can keep all the surfaces and the mating surfaces, because generally you don't mate to curved surfaces or tapered surfaces unless you've got an assembly. But that doesn't apply to this, because it's taking a snapshot of your model, it's not affecting your project, and it's keeping it aside as you saw before. So these files are important. If you actually do miss them and they're not in your weldment profile, or you've created a new weldment profile and you want to update something, say for instance there's a weldment profile that we may not have in the tapered flange, and you need to add another weldment profile configured size, you also have to go back to the DSTV and update that file as well. Just be mindful that it has to happen as well. So when a weldment profile is added to the library, the data needs to be also added to the database. So we have a weldment profiles data tool, which allows us to collect the data for each country. In this particular case, I've only got the Australian data installed. So you can see here that it's been grouped already for us to see what the data is. However, if I wanted to, I could clear the grouping, and now you can see all my sections. And when I click on my section, you can see that I've got an image here to the right. This image and the location of the location points all are related to the images that we have sitting inside our weldment profiles. This is the reason why we have images as well as the weldment profile. SolidWorks does not allow us to capture a snapshot image of a weldment profile, so we've just created an image for ourselves. So in this instance, you can see that this is an I-beam type beam. So in Australia they're called UBs or UCs, or they're the two, UB and UC. So if we go down and have a look at a UB, you can see that there's the image, and that image there is being utilized. So in each one of these, this is data that's been uploaded to the library. This data is collected by DSTV and it's used in working out where the top flange is, where the web is, and where the bottom flanges are. And if you wanted to create a new weldment profile that you want to use DSTV on, be mindful that we've got a limitation on what weldment profiles you can use. That limitation is pretty much straightforward. It's channels, it's angles, it's SHSs or rectangular hollow sections, it's I-beams, and that's predominantly the sections. We don't have T's working yet. That's something that we'll add into the future, and CHS. So this is the data that gets uploaded. Now if you want to upload your data and you have a weldment profile that we don't have, you can download the sheet template, and that sheet template is where you put your data and how it's set up so that it can be imported by a bulk upload process into the so you download the Excel template from here and you download the libraries from our web server here. So if you download the Excel spreadsheet, you can populate that with information and then upload it so that then becomes part of your database. This information is important and it has to match that of the weldment profile, otherwise it'll miss it. So obviously the section size name has to match that of the configuration name in the weldment profile, otherwise it will not find it. So this data is important. Be aware that it exists, and we need it when we're doing DSTV CNC NC1 export. So that pretty much concludes DSTV CNC demonstration. We know that different machines can operate differently. If you have any issues with any of your DSTV files, please send them to us. We actually have a folder in our system called 666. They're the devil components. They're the ones that we've missed, or they have something complex in them that we struggle to do, and we will put them in there and see if we can help you out with them from our end. If you do have any problems, please, as I said before, zip up the DSTV files and send them to us, and we'll be onto it straight away for you. Send your email to support@cadcraftsman.com. We're here to help, and we're here to make sure that you can create your DSTV CNC files. Yeah, thanks for your time, and we look forward to seeing you in the next demonstration.